Okay, let's do our first entire run-through of a full hypothesis test. So here is our information. In one Florida election, 47% of all registered voters voted. So notice that I'm going to try to pick out my values, like what are these numbers and what do they represent as we go. So this is our p-value. That is the actual percentage of the whole population. That 47% of all registered voters voted. A researcher studying the behavior of academics was curious about whether political scientists voted in the same proportion as the rest of the people in the state. So to answer this, the researcher took a random sample without replacement of 54 political scientists who live in Florida, and he interviewed them to determine whether they voted in this election. As it turned out, 40 of the 54 scientists in the sample voted, which is a sample proportion of 0.74 or 74%. So this is our p hat. P hat is 0.74. That's the percentage from the sample. We're going to carry out a 4-step hypothesis test to determine whether the proportion of all political scientists who voted in this election differed from the proportion of the general public. Okay, so let's state our hypotheses. We need to state our H0 and our H alternative. So again, our H0 always has to be the default position, that nothing exciting is going on and that nothing has changed. The H0 is the boring one. So what would be really boring here is if the percentage of political scientists was actually exactly the same as the rest of the population, if it was still 47%. Now, specifically, what we would like to try to provide enough evidence for is we want to see if the percentage is different from this. So this is going to be a 2-sided hypothesis test because we don't really care if it's up or down. The only question we're trying to answer is it different? That's all we care about. So we want to know, is there enough evidence to support this? Is there enough evidence for that? That's what we're going to carry out here. Okay, let's see. We need to set up our own significance level. We haven't been told what to use, so let's just use the default, alpha equals 0.05. And because we are working with proportions, everything in here is a proportion, then what we are going to use as our z statistic is the only one, again, we know so far, which is the z. Let's check our conditions, make sure we are allowed to carry this out. So first condition is, do we have a random sample with independence going on? So let's make sure we found the keywords. This is a random sample, so we're good here. Is the sample big enough? Do we have a large sample? So we have to check, is NP greater than or equal to 10? And is N 1 minus P greater than or equal to 10? Our N would be 54. And our P we already had labeled, that's 0.47. So we want to check, is that greater than or equal to 10? And is 1 minus, is that greater than or equal to 10? So let's just figure out what that is. If I multiply out this first one, I get about 25, so we're good there. And on this one, I'm multiplying 54 by 0.53. And if I multiply that out, I get about 29. So we're good on both of those cases. The last condition to check is, did we have a large enough population? So is the whole population greater than or equal to 10 times the sample? So we know our sample was 54. We're checking to see if something is more than 550. So what was the population? Where were these people chosen from, these 54 people, it looks like they were chosen, they had to have been a political scientist in Florida. Like that was the qualification in order to actually be chosen. So that's my population. Do we think that there's reasonably more than 540 political scientists in Florida? I would say yes. That's reasonable to say that. So we are good on our conditions. We can proceed. That's really the longest part. The longest part of these hypothesis tests are setting them up, which is step 1 and step 2. Now we are going to use StatCrunch to calculate this z statistic and the p-value. So we're going to get a z and a p when we go into StatCrunch. As a reminder, what we're going to need to tell it is we're going to need to give it the number of successes and the number of observations. So we definitely observed 54 people. And the successes are the ones that come back what we're interested in. So what we are interested in are the political scientists who said they voted. So it looks like there were 40 out of that 54 that would be considered a success for us. Okay, so then let's go ahead and go to StatCrunch. We're going to go into, again, our proportion stats. This is a single sample. We definitely have summary data. So it's the same place we went in all of chapter 7 when we were running our confidence intervals with proportions. The hypothesis tests are under here as well. So same kind of setup. The successes were 40 out of 54. Instead of changing it to confidence interval, though, now we want to leave it on the hypothesis test option. But you're almost always going to have to change these hypotheses, change them to match what we had written on our paper. So what did we write as our H sub naught? We had P equals 0.47, and we had as our H alternative, P does not equal 0.47, so that pops up automatically. Notice under here you can change it to greater than or less than if we need that, but this one we were doing the double-sided anyway. So we can go ahead and compute. Now I'm going to click this extra option down here for a p-value plot, and I'll show you what that gives us. It gives us an image of what we're looking at here. So the two values that we want to record are the last two in the table, the z statistic and the p-value. So I'm going to flip back over and record those, and then I'll show you what came up in that other area. So z was approximately 3.99. from that other page, and P, all it said for us was it said P is less than 0.0001. So P came back so incredibly tiny that they cut it off at a certain point and they just say, hey, it's smaller than this. Okay, so let's go ahead and interpret. The z-value is important to us, but what's most important to us is the P, because our conclusions are based on that p-value. So because that P, I'm going to say since P came back, we compare it to that alpha value. Is this P greater than or less than 0.05? Well, here it's extremely tiny. It's definitely less than 0.05. When your sentence is short, or when your p-value is small, your sentence is short. So our answer here is we reject. Sorry about that. Can't spell. We reject the null. So we are rejecting this idea right here. We're saying, nope. We've actually found enough evidence to go with the alternative. So that's how I can write my conclusion. I can say something like, there is enough evidence to say, and what were we trying to say? We were trying to say that political scientists vote in a different proportion than the rest of the public. So I can say that. That is all I was trying to show. I was trying to show enough evidence that they vote differently. I have not tested whether they vote more or less. The only question right now was different, so I found enough evidence to go ahead and say that. Now, what does this look like? That's what comes up on that second page of StatCrunch if you choose to have it plotted. But so what this is saying is Z came out as 3.99, but this was a two-sided hypothesis. So what that means is way out here at, let me see if I can get it to stay. Might not be able to. Way out here at about 3.99, that tail, that upper tail and farther out is what is shaded. And the same thing back here at backwards at 3.99 and there. So that what it's doing is saying those are our z-scores basically. This was two-tailed, so we could go out to either one of those and say the shading that's beyond those values in the tails, that represents my probability. So notice there's basically nothing out there, right? There's hardly anything shaded beyond 3.99 in either direction. That's why our p-value came back so incredibly small, because the p is the area that's beyond that. So that's what shows up in your plot. So it's just a prettier image than the one that I was trying to draw. So it shows you those markers at the positive and the negative 3.99. And we're saying past that is the probability that we're talking about. Incredibly, incredibly tiny, which is why we came up with the result that we did. This was an extremely surprising result. If we thought it was 47% and the sample proportion we got back was 74, that was a very, very big difference. That is very unlikely that happened kind of by fluke, that we just so happened to take a sample that had a lot more political scientists that voted. What this is saying is more than likely, if we were to do this over and over again, if that 47% was true, we wouldn't keep getting things that are so far away. So now I'm like, I don't think this 47% number is true, not for the political scientists. So that's how the surprise is measured, right? Our p-value is very small, so we are very surprised by the result that we're getting. And that's what makes us kind of jump ship on our H0 and go with the alternative.